Hello everyone, this is K. Sandhya Rani, and in this video I would like to discuss about inverse Laplace transformation of the partial fractions in the subject Lncv. So before starting with these partial fractions, let us try to recap our previous knowledge, which is nothing but how to split the partial fractions of the given function. Okay, so let us take one example here. So while splitting out the partial fractions, first, in which situation we are supposed to utilize this partial fractions means whenever the given function is like this, 1 by s minus 1 into 1 by s minus 2, linear factors. In the denominator, whenever we have product of factors, combining like some are linear factors, some are quadratic factors. So now we are discussing about linear factors. And here we have two linear factors in the denominators. When in this case, how to write the partial fractions? A divided by first linear factor plus B divided by second linear factor. That is S minus 2. Like this, the partial fractions of linear factors existing in the denominator should be splitted. In another case, 1 by S minus 1 into S minus 1. Means S minus 1 is repeated for 2 times and S minus 2 is obtained only once. So how to write a partial fraction for these? First A by S minus 2, let us write. Okay, plus B divided by S minus 1 plus C divided by S minus 1 whole square. So like this, the partial fractions have been splitted when repeated factors are there. Next case is quadratic factors. S square plus 1 into S square plus 4. Okay. So next, two quadratic factors repeated only once. In such case, how to write means for first quadratic factor, we should write as AS plus B divided by S square plus 1. For second quadratic factor, we should write as CS plus D divided by S square plus 4. Okay. And here also we can have a repetition in the quadratic factors. Then how to write? S square plus 1 whole square into S square plus 4 whole square. Otherwise, we can take it as ones. So then how to write them? First here, let us write this S square plus 4 is only once it has been occurred here. So therefore, 1 by, not 1 by AS plus B divided by S square plus 4 plus next one is CS plus D divided by S square plus 1. Okay. And one more time we should write that is ES plus F divided by S square plus 1 whole square. Since this S square plus 1 is repeated twice, we are supposed to write two fractions for this S square plus 1 as we have written for S minus 1. Okay, so these are the different ways where we are trying to split the given fractions with linear or quadratic factors in its denominator into the partial fractions. Okay, so based upon this basic information, we are going to evaluate inverse Laplace transformations of the given functions here. Okay, here you see, if we take a basic example, here the function is given as 2s plus 5 divided by s square plus 5s plus 6. And here we know that this quadratic expression s square plus 5s plus 6 is 5s plus 6 is splitted into s plus 2 and s plus 3. Okay, so a by first factor, since these two are linear factors, s plus 2 is a linear factor, s plus 3 is also a linear factor. Okay, these two are linear factors and repeated only once. Okay, so a by first factor plus b by second factor we have to write. And later on we need to take LCM for these two. Okay, we need to take LCM for these two and we need to find out a and b values here. So if you put s is equals to minus 3, we are going to have a value as 1. If we keep s is equals to minus 2, we are going to have a as 1. S is equals to minus 3, b we are going to have 1. So therefore, the same function 2s plus 5 divided by s minus 2, s plus 2 into s plus 3 is written as 1 by s plus 2 plus 1 by s plus 3. Okay, so therefore, now L inverse of 2s plus 5 divided by s square plus 5s plus 6 is written as inverse Laplace transformation of 1 by s plus 2 plus 1 by s plus 3. Okay. So therefore, according to again linear property, inverse Laplace transformation of 1 by s plus 2 plus inverse Laplace transformation of 1 by s plus 3, which is nothing but e power minus 2t plus e power minus 3t. So this is our required answer for the given inverse Laplace transformation of 2s plus 5 divided by s square plus 5s plus 6. Okay, so like this, the partial fractions will be utilized to determine inverse Laplace transformation of the given function. So after this, let us see a few more examples. One more example. Here we can see quadratic factor also. So here 6s square minus 8x minus 4 divided by x square minus 4 into x minus 1 is there. So it has been split into like this, you see, by using partial fractions. If we want to find out inverse Laplace transformation of 6s square minus 8s minus 4 divided by s square minus 4 into s minus 1, which is equals to inverse Laplace transformation of 1 by x minus 2 plus 3 divided by s plus 2 plus 2 divided by s minus 1, which is nothing but e power 2t plus 3 into e power minus 2t plus 2 into e power t is the required answer. So what we are doing, whenever the case arises, like we are supposed to find out inverse Laplace transformation of any fractional rational function. By using this partial fractions, the rational function should be split into number of terms. And this number of terms will be of a standard functions in inverse Laplace transform. Right, so that we can directly apply the inverse Laplace transform for each and every terms to have its respective answer f of t. So like this, these are the important points as to be memorized, and the procedure should be evaluated. The procedure should be followed to find out inverse Laplace transformation of the rational functions. And this partial fractions is most important important procedure which will be utilized to find out inverse Laplace transformation of all rational functions. Okay. So with this, we completed inverse Laplace transformation of the partial fractions. Okay, everybody.